Okay, see Lindelof videos, polynomial division with remainders. Woot woot. I admit I've done videos like this before, so I apologize, but these couple specific questions were asked of me, and I was asked for a little review of how this stuff works. So Mark Kelly, here you go, buddy. So here we go. Just a quick reminder, I'm sorry, but just of how regular division works, because all the rules work out the same, right? We take this number and we go into the first number, then the second number, third number, or whatever we can get right. So just going to do that, right? I'm going to say how many times does 2 go into 3? It goes in 1 time. So we divide first, then we multiply. 1 times 2 is 2. Then we subtract. I'm trying to get this algorithm down in our heads. We subtract, right? The way we subtract is we add the opposite here. 3 minus 2 is 1. So we divided, we multiplied, we subtracted. Now we bring down. I'm sorry, but this is going to get super important in a minute. So I'm going to bring this 7 down. The 7 is here. So that gets us back to the front again. And then we're going to divide, right? 17 divided by 2. What can we get without going over? I think we get 8. 8 times 2 is 16. So we divided, we multiplied. Now we subtract whatever number this was. We take its opposite. Now, this opposite crap is going to be important later. You can be like, oh, I see why he's saying that. 17 minus 16 is 1. Right, so we did our subtraction. We're going to bring down 9. I hear you guys are like, I get this, shut up, but it's important. 19 divided by 2 is 9 without going over. 9 times 2 is 18. 19 minus 1 is, 19 minus 18 is 1. So check this out. If we were in middle school, we'd write 189 remainder 1, right? But we're not. If you're watching this, you're either in intermediate college algebra, or you possibly, depending on what school you go to, you're in algebra 2. So just want to point this out. When you have this, see this 1 right here and this 2 right here, what we're trying to figure out is what part of that do we have. So what we're going to see, instead of this subtraction, instead of this R, we're going to see this. We're going to see this number down here, 1, over this number here, so over 2. Be careful, it has to be a plus here, right? Plus this, right? So plus this. So this is how we put our remainder in. Kind of gets super important as we move forward. So remember, when we have a remainder, we're not going to write it as R, right? That's not where we are. We're going to write it as a fraction, where this is the numerator and this is the denominator. Hopefully you're going to remember that I said that. So here we are with this crap right here. If you see it this way, you could also see it this way from your professor or your teacher. You could see it written this way, n plus 5 at the bottom. So if you see this, it means this. The way we're going to do it is to see it like this. We're going to have top or numerator divided by denominator. So we're going to have n squared plus 10n plus 18 in the box. And then we're going to have n, this is important, you're like, why is he writing it this way? You'll see in a second, plus 5. Because when you do polynomial division, you only use the leading term. So right now we have a binomial term, but if it was a trinomial term or any amount of terms, you always follow the first term. So, and then the rest of it follows, which will make sense in 1 second. So we're asking ourselves a question. How many times does n go into n squared? That is to say, what multiplied by n gives us n squared? And that number would be n, wouldn't it? So n is our first number. N times n is that n squared that we were looking for. But remember, you have to take all of it. So n times n is n squared. Then n times this positive 5 right here is positive 5n. This is where people screw up because, right, we just did our division, we did our multiplication. Now we're on our subtraction part. And our subtraction part, right, usually you just put a negative sign here, but whatever this is, you take the opposite of this, but you take the opposite of the second term and third term, however many terms you have, you take the opposite. So this is positive, so it becomes negative, right? Now we do our subtraction. N minus n squared is nothing, but 10n minus 5n is 5n, right? Now we're at bring down. We're going to bring down this 18, so we're bringing down a positive 18, right? So positive 18, right? We're back at our divide part. We're only looking at the lead term. And we're asking ourselves, what times n gives us 5n? And that is 5, isn't it? So 5. 5 times n is 5n. That worked out good for us. 5 times 5, though, right? Remember, we have to follow this whole thing. So this times this, and then back this times this is positive 25. Remember, when we were in middle school or elementary school, we just subtract this. We just subtract whatever number we had, but we had to subtract this whole quantity here. So this is positive 5n, so it becomes negative 5n. This was positive 25. It becomes negative 25. We good? 0 here. 18 minus 25 is negative 7. Right? So that gives us, as our answer, we have this up here. So we have n plus 5, right? We have a negative 7, so negative 7 over n plus 5. If you're wondering why I've dragged the negative out to the front, it's because it would look stupid if I didn't. Sorry, not cool. Just remember this rule, please, that if I have negative AB, it's exactly the same as negative A over B, which is exactly the same as A over negative B. And when you're cleaning up your algebra, you really want it in this form. So if you have this or this, you want to drag this up to the front or this up to the front. So in a perfect world, your professor would prefer to see it this way. Is that cool? So that's why this was negative was up here, and I just dragged it down to here. So here's our answer. Cool? I'm only going to do one more problem because I don't want to keep you tonight. But so this problem is really interesting because, so let me show you this and see if this makes sense. If I do 2 into 504, this 0 right here is a placeholder, isn't it? That is to say, if I took out the 0, I'd have 54 divided by 2, and they are not equal. But the 0, right, the 0 is just a placeholder, and that's going to make sense right now, right? Because we need to put these in terms of our highest one we have is a squared, right? So we need a squared and everything down. So we have a squared, and then we need our a to the first and our a to the 0. Remember, a to the 0 is 1 unless a is 0. So check this out. This is what I'm doing. So I have this a minus 5 is this piece right here, right? Now I'm going to divide here. We have a squared minus 0 a's to the first, right? Remember, a to the first is the same as a. I just put it here so you can see it. Minus 28. Check me out for a second. As weird as it is, this is squared to the first, and this is to the 0. So we have all the pieces that we need. It's really important because this is a placeholder. And if you don't, your math won't line up correctly, and your answer will come out really screwy. So take a second, remind yourself. Placeholder. If needed. So how do you know if you need it? Well, if you don't have it in this form, right? If this thing right here is not in this form, you need that placeholder. All right. Sorry to rattle on, but this is one of the ways that people get turned around, and a lot of teachers and professors kind of miss this part, and students are like, "Oh, the hell didn't this work?" So how many times does a go into a squared? Well, it goes in a times, right? We're going to follow this. A times a is a squared. Of course, you got that. But remember, you're going to go back. A times negative 5 is negative 5. Remember, we were supposed to subtract next, right? We did our division. We did our multiplication. Now we have to subtract. Remember, we have to subtract the whole term, which is to make it opposite. So this negative sign, negative times a positive is negative. Negative times a negative is a positive, right? We have opposites here. Super important. So where does that get us to, you guys? That gets us to, we're still in our subtraction piece. So a squared minus a squared is nothing, but negative 0 a's plus 5 a's is 5 a's. That gets us to the bring down part. So I'm going to bring down this in total, right? This is not just 28, it's negative 28. So remember to bring the whole thing down, minus 28, right? Same thing last time, right? How many times does A, always the lead term, how many times does A go into 5A? Well, it goes in 5 times, doesn't it? 5 times A is 5A. Follow the whole piece of math here. 5 times negative 5 is negative 25, right? Remember, I swear to goodness, I know you can hear me in your head. Subtract all terms, right? Which means distribute an opposite sign. Negative sign is an opposite sign also, isn't it? So the opposite of negative 5a is negative 5a. The opposite of negative 25 is positive 25, right? 5a minus 5a is nothing. Negative 28 plus 25 is negative 3. So this is our remainder. So we know that we're going to put this over this. So our answer is a plus 5, right? That's from here, a plus 5. This is a negative 3. We're going to bring the negative down to the middle of the solidus. The 3 is up. A minus 5 at the bottom. Cool. All right, you guys, I really hope this was helpful. If you have any questions or comments, let me know. And if you haven't already subscribed, will you please subscribe? I appreciate it. All right.